In this video, we're going to do the last factor that could influence equilibrium or may not. We'll take a look. This is called the catalyst. We'll see how we can graph that and model what happens when you put a catalyst into a system that's at equilibrium. And then we'll also model putting a catalyst in before your system has reached equilibrium, because that's actually two different things. So when you add a catalyst, as we've already seen, it will not change the K. So the K will be constant. K is constant. Now, suppose we are starting the reaction without a catalyst and we let it reach equilibrium. So we're doing this reaction here. We're going to have some HCl starting off at 0, and then it's going to increase like this until it stops increasing. And then our H2 and our Cl2, they're going to decrease. Just a little bit less. Actually, I want to make that more pronounced just so we can see the difference here. So let's go back and do that. So this one here will increase. These two here will decrease. And at the point where they flatlined, that's where equilibrium has been reached. This decreased by, let's say, 1x. This decreased by 1x as well. And this increased by 2x. So now we're at equilibrium. And what we're saying is let's add a catalyst in. So at the beginning, we didn't have a catalyst. Let's add a catalyst in. When you add a catalyst, if you've already reached equilibrium, there's no shift that's going to happen. Nothing is going to happen at all. That's because we speed up the rate of the forward and the reverse equally. So they both speed up at the same rate. And so it will not change the concentrations. It will not lead to a shift. So essentially, if we start without a catalyst and we reach equilibrium, let's say around here, let's call this 4 seconds. Once we're at equilibrium, putting a catalyst in won't really do anything helpful because we're already at equilibrium. Now, suppose instead we started the reaction with a catalyst in there as well. Now, something different will happen. It will allow you to reach equilibrium faster. So here, for example, it took me up to 4 seconds for the concentrations of everything to stabilize. So if I start with the catalyst, I'll reach the same concentrations, assuming I start off the same way with the reactant concentrations. I'll reach the same concentrations, just faster. So it'll still be a curve, just a steeper curve here. And now I've flatlined at that same level. But let's say it's about 2 seconds in instead of 4 seconds. For the hydrogen and the chlorine, it's kind of the same idea. So I flatlined around here, which is a little bit earlier, sooner. So about 2 seconds in. I'm just making those numbers up, but the point is I've reached equilibrium faster when I've added the catalyst at the beginning before equilibrium was reached. And then once equilibrium is reached, if I put another catalyst in, it won't change or shift anything overall. So essentially, here is where the equilibrium is reached the first time when I didn't have a catalyst at the beginning. And once I've reached equilibrium, if I try to add a catalyst in, it will speed up both the forward and the reverse reactions at the same rate, essentially. They both speed up to the same factor. But we will see no change in concentration. Okay, so it's kind of like if you're doing a race with someone, and you're both tied, then you decide to speed up, but then that person also speeds up at the same speed that you went to. So now you're still both at the same spot. So it looks like there was no change relative to each other. So it's kind of the same thing with the when you're already at equilibrium. Yes, we'll speed up, the forward, but we'll also speed up the reverse. So it still looks like nothing has changed overall. Concentrations do not change because you speed both up at the same rate with the catalyst. Now, if you put in the catalyst at the beginning, so before equilibrium was reached, then you'll reach equilibrium faster. So equilibrium is reached sooner. But K would still be the same. All right, so when you put in your, let's say you were making a K expression here, so K is equal to HCl squared over H2 times Cl2. If you put in this, this, and this into here, and here, you'll get a number. If you then take this, this, and this with the catalyst and put them into here, they'd be the same concentrations anyways. You'd get the same K value. So you'd be at the same concentration as without the catalyst, but just it happened earlier. And that was the final factor that we saw that might influence equilibrium in some way. Catalysts do not shift the equilibrium. They just allow you to reach the equilibrium faster if you add the catalyst prior to reaching equilibrium. That concludes the graphing Le Chatelier. You should be able to model Le Chatelier's principles graphically and also interpret graphs based on stresses that have been provided or illustrated on the graph and explain why those changes are occurring.